Okay. Good evening, everyone. So today we'll be discussing current electricity. So in current electricity, first we have some theory based on conductivity, resistivity, and Ohm's law, drift velocity of electron inside conductor. They are formula based questions directly you'll get in exam, JEE means. So be thorough with all the list of formulas in the initial portion of the chapter. So first is when we talk about conduction. So if you take any conductor and if you apply a electric field across the ends of the conductor or a potential difference across the ends of the conductor, then electrons, we know that it will be going in random path after successive collision. So average velocity of all the electrons, that is called as drift velocity. So drift velocity is average velocity of all the electrons inside a conductor when you are applying some electric field in the conductor. So if you apply electric field in one direction, force on electron will be in the opposite direction. So all of them will be drifting towards the right side. So in this case, drift velocity is given by acceleration into time. Average velocity means acceleration into time between successive collision. So acceleration is force charge into electric field divided by mass into tau is average time between two successive collision. So drift velocity is E into electric field by mass of electron into tau, right? And then current and drift velocity have a relation. Current will be equal to NEAVD, where A is the area of cross section, VD is drift velocity, area of cross section of the conductor through which electrons are moving, right? N is the number of electrons per unit volume. So here you can put the value of drift velocity. So you get a term Ne square tau divided by m, which is a constant. This A you can bring here, I by A into electric field. So this is another form for this. So here you get J is equal to current density. So this current density, current per unit area, J is equal to some constant into electric field. So the constant is called as sigma or conductivity of the conductor. So that is your another form of Ohm's law as well. So this formula for drift velocity, current in terms of drift velocity, from there equally you can substitute and prove that J is equal to some constant into E, which is called as sigma or conductivity, right? So in this case, apart from this, you also have mobility. So mobility is drift velocity per unit electric field. So what is the value of mobility? So drift velocity per unit electric field means E into tau by m. So it is a constant for a particular material. So there is another formula regarding this, and your Ohm's law again. Normal V is equal to IR. I hope you are familiar with this. But the other form of Ohm's law also you have to remember, which is this one. That's easy to derive from here also. In fact, this is your starting point. This is the derivation for Ohm's law as well, which you'll be having in your NCERT exams. So these are the set of formula. Here also you can write J is equal to Ne into Vd, because I by A is current density. So you can write another form of this is J is equal to Ne into drift velocity, right? So if you have V is equal to IR, in fact you can write resistivity is rho L by area, and then I by area is current density into rho potential drop across the conductor divided by length. So V divided by length will be your electric field. Electric field potential drop per unit length. So this E is equal to rho into J. So this is one form of Ohm's law, and this is another form of Ohm's law. That is what we got here. I wrote it as sigma. So conductivity, this is resistivity. So conductivity is 1 by resistivity. So you can write this as 1 by rho into E. I hope it is. Yeah. So you can write J is equal to sigma E. Sigma is 1 by rho. So J into rho will be electric field. So these are the main set of formulas in the theory part that you have to be thorough with. You can get directly question based on this set of formulas also. And then another one is variation of resistivity with temperature for a conductor. So variation of resistivity with temperature is rho naught into 1 plus alpha into change in temperature. So rho naught is the initial temperature. If you increase the temperature of the conductor by delta T, then this will be the new resistivity. This is at suppose temperature T naught plus delta T. This at temperature T naught. So increasing by delta T, then the resistivity gets multiplied by 1 plus alpha delta T. Or you can also rearrange this rho minus rho naught is equal to rho naught alpha delta T. This is final resistivity minus increase in initial resistivity. So change in resistivity is depends on initial resistivity, alpha, and change in temperature. Alpha is temperature coefficient of resistivity. Okay. So for a conductor, as temperature is increasing, alpha will be positive. As temperature is increasing, resistivity is increasing. Right. Right. Let's discuss a question that was asked in your February attempt based on this. So you have a cylindrical wire of radius 0.5 mm and conductivity. Some value is given for conductivity as well. 5 into 10 to the power 7. SI unit. So SI unit of conductivity is SI 1 by resistivity. Okay. So in this case, we are subjecting this cylindrical wire to an electric field of 10 millivolt. Electric field of 10 millivolt per meter is applied across the two ends of the cylindrical wire. So across the wire. So based on the information given here, you have to find what is the value of current in the wire. So in fact, they are given current in the wire is 5 into x cube milliampere. So you have to find x. Right. So how do you approach this? Just directly remember the other form of Ohm's law. J is equal to sigma into E. So current density is conductivity into electric field. So in this case, electric field is also given, conductivity is also given. You can find current density, and current through the wire is current per unit area of cross section. Since it's a cylindrical wire, area of cross section will be pi r square. So convert everything to SI units. Be careful with the values. So you can write J is I into A equal to sigma into E. Current is this value pi x cube. Since it's milliampere, put 10 to the power minus 3 into area of cross section is current per unit area. The current density is I, current per unit area. So divided by area of cross section is pi r square. Radius is given as 0.5 mm. So into pi into 0.5 into 10 to the power minus 3 meters, the whole square. This will be equal to conductivity is already given as 5 into 10 to the power 7 into electric field is volt per meter is SI unit of electric field. Millivolt per meter means convert to a SI unit. 10 into 10 to the power 3 minus 3 because millivolt means 10 power minus 3 volts. This now everything is in SI unit. So you'll from here solve this and you can find the value of x cube. So I just wrote the value so that you are clear with conversion of units. So always make sure that all the values are in SI unit. Then answer also will be, we are getting the answer in ampere SI unit. That's why this value I wrote it as 10 to the power minus 3 amperes. Okay. Right. So then we have circuits. First we'll see simple circuits, series parallel combination. I just give the formula and just give a sample question. And we'll go to different types of circuits that you can get in this concept. So in case of circuits, for series combination of resistors, so you have two resistors. They are said to be series. If current flowing through one of them is flowing through the other resistor also, then they are said to be in series. So in that case, this can be combined as equivalent resistance. You know the equivalent resistance is R1 plus R2. So that total current in the circuit or so whatever is the total voltage drop supplied by the battery, that potential difference is dropped across the two ends. So V is equal to I into R equivalent. Here equivalent resistance is R1 plus R2. So if EMF of the battery is given, you can find current through the circuit. Similarly for parallel combination, if the same potential drop is applied across the two resistors, then you can combine these two as one single resistor. They are in parallel combination. So 1 by R equivalent is 1 by R1 plus 1 by R2 and so on, plus 1 by R3 and so on if you have multiple resistors in parallel. For two resistors in parallel, there is a short formula which is useful in most of the cases. If you solve this, you will get the answer as R equivalent is product by sum, R1 R2 by R1 plus R2. This can be used to directly find the effective resistance if there are only two resistors. If there are three or more resistors, go with the general formula 1 by R equivalent is sum of 1 by R. So this is applicable here also. Here I is the net current drawn from the battery and V is the voltage drop across the battery. Okay. Another thing is how current is splitting through a parallel combination. If suppose there is a current I entering a junction and you have two resistors in parallel, R1 and R2, then the current will split. I1 plus I2 is equal to I and I1 R1 is equal to I2 R2. Potential drop here is equal to potential drop here. We will get one equation. Current entering will be equal to current leaving. So I is equal to I1 plus R2 will give you another equation. So from here you can find what is the value of I1. So the result you can remember. Current through this resistor is total current entering the junction into the other resistor R2 divided by sum of two resistance. Again, this formula is applicable only if you have two, it is splitting into two branches. For multiple branches, you have to write the general equation and derive the same. Similarly, for I2, current into the other resistor R1 divided by sum of two resistors. These are some important formulas that you should know before solving basic questions from this series and parallel combination. Okay. So let's see a couple of questions from this. Last year JEE main question. Right. These points are given as A, B, C, D. So across this AC, a battery of potential 40 volt is connected. So in the question, they have asked you to find potential difference between point B and D. So what is the value of potential difference across B and D? So potential difference across B and D. So how to approach this question? So here first you can simplify. This battery is connected into two branches. Above branch you have one resistor. These two are in series, right? Because same current is entering, and these two are in series. So whenever you have multiple parallel branches, each of the current you can find separately. 40 volt is applied across these 2 points. So from here to here, there is a total of 40 volts, which means if some current I1 is flowing here, same current I1 is flowing here, total potential drop is 40. So if you take a above branch, this potential drop equal to I1 into total resistance, which is 60 plus 40, that is 100. So I can write 40 volt is the potential drop across AC, that is equal to I1 into 40 plus 60. So from here you get the value of I1 as 40 by 100 or 0.4 ampere. Similarly, you can find what is the current through the lower branch, I2. The same potential drop of 40 volts. If you see, while finding I1, this resistor didn't matter. This resistor didn't matter because multiple parallel branches are there. Current through each of them depends only on the what is the battery it's connected to. Okay, assuming ideal battery. So each branch separately you can find the current. So this I2 will be equal to this potential drop of 40 volts applied across these 2 points. That is this current into this resistor. So total resistance is 90 and 110. They are in series. So this will be equal to I2 into 90 plus 110. This is 200. So I2 is 40 by 200 or 20 by 100, 0.2 amperes. Now they are asking potential drop across B and D. Right. So can I say potential drop across BC is I1 into 60? Potential drop across BC means what? B is at higher potential. So potential of B minus potential of C, because current flows from high potential to low potential. So potential of B minus C is I1 into 60. What is I1? 0.4. So 0.4 into 60, or that is 24 volts. Right. Just a minute. That is potential drop between B and C. Similarly, potential drop between D and C, higher potential, lower potential. So potential at D minus potential at C is equal to I2 into 110. I2 is 0.2 into 110, 11 into 2, 22 volts. We want between B and D. So subtract both the equation. VB minus VC minus VD minus VC. So when you subtract both the equation, this term will get cancelled. You get VB minus VB directly. So equation 1 minus equation 2 means VB minus VD is equal to, right, this term minus this term. So this minus of minus plus both will get cancelled. So if you subtract these two equations, you can find what is the value of 24 minus 20, which is 2 volts. So you can get the potential drop between these 2 points by this method. So just find the current through each branches. Then this potential difference, this potential difference, with respect to same point, with respect to same reference. This from here, this point is extra by 24 volts. Compared to this at extra potential of 22 volts. So this 24 volts extra, this 22 volts extra. Between these two differences 2 volts. That is what we have done using equations. So is this clear? Now the next concept is Wheatstone bridge. Somewhat similar circuit only. These two potential, we are trying to find difference, right? For one particular value of resistors, these 2 points will have same potential. That is Wheatstone bridge. So in Wheatstone bridge, some resistor R1, R2, R3 and R4. Right. You can also draw it like a rectangle. Shape of the circuit doesn't matter. Only how the connections are given. That is what matters. So the equation is if R1 by R3 is equal to R2 by R4, or this by this is equal to this by this. Anyone, both are same. So if R1 by R3 is equal to R2 by R4, then these 2 points A and B, potential drop A is equal to potential of B. So there is no potential difference between A and B. If there is no potential difference, even if you put a resistor in between, that is useless because potential drop across the resistor is 0. Since potential drop across the resistor is 0, current through the resistor will be equal to 0. So this current will be 0, which means whatever current is coming here, it will go here. This current is 0. Whatever current is coming here, it will go here. So you can remove this resistor and then solve the circuit simply if this condition is satisfied. So this is your Wheatstone bridge. So sometimes you might not be you should be careful in figuring out the circuit and identifying when it's a Wheatstone bridge or not. Okay. So direct question, I'll skip that. Like this Wheatstone bridge concept which you can apply. But one important thing to understand here is it is also applicable in case of extended Wheatstone bridge. What I mean by extended Wheatstone bridge? Suppose if you have 2 ohms, 2 ohms, 4 ohms, 4 ohms, again 2 ohms, There's a question in last year JEE mains with this circuit, and there were some resistors connected in between. So in fact, in that question they are given this was not connected. So I add this circuit. These two are 5 ohms. Some battery value was given. They asked you to find the current in the total current in the circuit. So in this question also, if you see here, this 4 ohm and this 4 ohm has nothing to do with this circuit. Even if it was connected also, the Wheatstone-Bridge principle will be applicable. R1 by R2, this by this are same, so it can be removed. But here, since this is not connected, whenever this wire is not connected, it is starting from here and ending here. It has nothing to do with this. You can simply remove this. Since anyway it's not going to be connected, it is not connected to this circuit. What you can do is you can simply draw this separately, 4 ohms, and put it over here. Is that correct? Because the line was given here, but they are not intersecting. There was an overlap, which means it can be drawn like this. Now this is a Wheatstone bridge, which means this resistance is useless. There is no current through this resistor. So you can remove these resistors. Now it becomes a very simple circuit. These two are in series, combine. These two are in series, combine. And then this and this is in parallel. You can combine and find value of total current. I hope that is clear. Then let's also see another question. This again came in your this year's 2021 February session. So it is given that all the resistors are of same resistance. So all the resistors are identical resistors. All of them have the same value of R. But the question they ask you to find what is the equivalent resistance between, find the equivalent resistance between these 2 points A and B. What is the meaning of equivalent resistance between A and B? If you connect a battery of EMF V, then current drawn from the battery is I. V by I is the total resistance between any 2 points. So equivalent resistance between 2 points means if you connect a battery of EMF voltage V and current I is drawn from the battery, V by I is equivalent resistance. Okay. So if you notice this carefully, I told you in correct electricity questions, only the how the connection is given is important. You can redraw it in any way you want without disturbing the connection. So this might look like a complicated circuit where from here it's going in this direction, another resistor, again it's coming back here to this point. But if you notice this particular wire and this particular wire, between these 2 points you have to find. So this point A along with the 2 resistors, you can lift it and put it on the other side. So this particular thing can be lifted and put on the other side. I'm not disturbing the connection. If you take it and put it here, then what will happen? From point A, there is a resistor to D, there is a resistor to E, there is a resistor to D, and there is a resistor to E. I have just taken it and put it on the other side. And D and E are connected by this resistor. Obviously, D and E are. So this is called, I'm just redrawing the circuit. in a slightly different way. So from A to D, A to E, A to D, A to E, these resistors I have included. Between D and E also I have included this resistor. Keep putting a tick mark so that you are clear with what you are drawing. And then from D to C, there is a resistor. So from D to a point C, there is a resistor. All of them are identical as given in the question. So this resistor also I have included. From E to same point C, there is another resistor. So from E to the same point C, there is another resistor. After that, it's connected to point B. Now, what is the equivalent resistance between A and B? Now, this is a very simple circuit, straightforward Wheatstone bridge. So instead of giving the circuit directly, it might be given in some other form. You might have to imagine that, or best way is try to redraw in rectangle forms, like rectangle or diamond shape things, so that it's clear that it's a Wheatstone bridge. So this resistance will not be playing any role. There is no current through this. So total resistance is R and R, 2R, R and R, 2R. 2R and 2R is in parallel. So equivalent resistance 2R and 2R in parallel means it will be equal to R. Because whenever you have R and R in parallel, equivalent resistance will be R by 2. So if there are 2 means R by 2. N identical resistors in parallel means R by N. 3 resistors means total is R by 3 and so on for parallel combination. That is another shorter formula that you can remember. So these are some questions on Wheatstone bridge. Then another important thing is writing Kirchhoff's law. That will be important in some questions. When you have multiple batteries. So circuits with multiple batteries are there, then you cannot simply say what is series, what is parallel. Those things cannot be written when you have more than one batteries. So if more than one battery is present, you will have to use only Kirchhoff's law to solve the circuit. So Kirchhoff's current law, I hope you know. Current entering, it's also called Kirchhoff junction law. Junction law or current law. Current entering any branch, any junction is equal to current leaving. Always remember, when you cross a battery and all, current will not change. So suppose if you have, I'll explain this how to solve this with an example of a sample question. So simply, it's not a straightforward series parallel question because you have 2 batteries. So whenever you have something like this having some voltage E1, voltage E2, R1, R2, R3, and R4. What you can simply do is current in one branch, whatever is entering the battery, same should come out of the battery. So whatever current is leaving the battery, same should come back to the battery. Just because you are causing a battery, current will not change. When current will change, only when you encounter a junction, it is splitting or it's combining, then only current will change. So you have to assume some variables and write equations. So here you can take, suppose if some current I1 is coming here, immediately put that I1 is coming back to the battery. And then same I1 is entering here. So if current I2 is entering here, I3 is entering here, battery is there, you don't have to worry about that. Write variables. So I2 will go through here, I3 will go through here. Again, it's combining. So at this junction, you can apply Kirchhoff junction law. Current entering will be equal to current leaving, which means I1 will be equal to I2 plus I3. This is your junction law. So again, I2 plus I3 is combining. It will become I1 because I1 is coming back to the battery. Right. So we got one equation. but there are three variables, I1, I2, I3. So for other two variables, you have to apply the second law, which is Kirchhoff's voltage law, or it's also called as loop law. So this is basically sum of potential drop in a closed loop is 0. Okay, you have to take any closed loop, total potential dropping across the loop will be 0. You start from one point, go through a loop, come back to the same point, you are coming back to the same potential, which means total potential difference when you come back to the same point is 0. While writing this equation, you have to be careful in writing plus or minus sign. So one method you can use, whenever you are crossing a battery, you can say potential is increasing. Direction in which you are going also matters. So if you are crossing a battery in this direction, then you are going from lower potential to higher potential. Potential is increasing. So put plus E1. And then if you are crossing a resistor, current is, you are going along the direction of current. So current will flow from high potential to low potential. Since you are going along the direction of current, potential will decrease. What is the decrease in potential? I1 into R1, current into resistor. So I'll write this for any closed loop. Suppose if I write the closed loop as A, B, C, D, E, F, again back to A. So I'll take the closed loop as junction law is easier to write, but voltage law you have to be careful with the signs. This is my closed loop. So you start from one point, go from A to B. As long as there is no wire, no potential drop. As long as there is no resistor or battery. Then when you go from B to C, you are going along the direction of current. So potential will decrease by minus I1 R1 is the decrease in potential. Then from C to D, you are going along the direction of current. You are going always when you go along the direction, potential will decrease. So minus I2 R2. Again along the direction of current, minus I2 R3. Then you are coming from E to F, no resistance, so no potential drop. You are crossing the battery from negative to positive terminal, lower potential to higher potential. So potential is increasing by E. You have come back to the same point A. So sum of all the potential drop is equal to 0. This is for the first loop. If you want for one more equation, because there are three unknowns, right? You can take another closed loop, this loop. So in this loop, if I take CD, E, again to G, back to C. So name the points and write the closed loop. So start from point C, we are going along the direction of current, minus I2 R2, along current, minus I2 R3. So minus I2 R2, minus I2 R3. And then from E to G. After E, you are going to G. So when you go from E to G, current I3 is flowing in this direction. So current is, we have assumed it's flowing in this direction. You are going from E to G means you are going opposite to direction of current. So lower potential to higher potential. So potential will increase. So plus, current is I3, resistance is R4. So plus I3 R4. This is the value that you have to write. And then you are crossing the battery now, negative terminal to positive terminal. So plus E2 is equal to 0. This is another equation. So I hope this is clear. So you can choose any direction for current. You may, if you are getting the answer for I3 as negative means our assumed direction is wrong. Current is actually in the opposite direction. So this is a sample circuit I have taken to explain the how to write plus minus sign majorly. We will see a couple of questions from last year based on when you had multiple batteries. There is no other way, you have to use only Kirchhoff's law to solve those questions. Okay. The question is, so they're asking find the current in 10-volt battery. So current in 10-volt battery is close to, which means they're asking what is the approximate value. Options are given, value, and then from negative to positive terminal or positive to negative terminal, what is the direction? That was also asked. So you have to find the current value as well as direction currently. So you have two batteries here, which means you'll have to use Kirchhoff law to solve this question. So how to write this? Again, you can start from anywhere. If you want, you can start from this battery also. Anyway, this value we have to find. So you keep that in mind. So suppose if current I is going here from this battery, immediately you write same current should come back to the battery. Whatever current is going to the back from the positive terminal, same current should come back to the battery. Now this current I is going through this resistor. It is splitting into two parts. So if current I1 is going here, try to minimize the variables immediately. You know that current entering is I, that should be equal to current leaving. So I is entering, I1 is going here means, suppose what is the value I2? I1 plus I2 is equal to I. So immediately you can write I is equal to I1 plus I2, which means I2 can be written as I minus I1. So I2 is equal to I minus I1. So this variable, we know the value of this. So immediately if you want in the diagram itself, you can write that. The value of I2, now I'll write it as I minus I1. So I1 is going here, same I1. Even if you cross the battery, current will not change. Same I1 is coming here. I minus I1 is coming, plus I1. So total I, which is again coming back here. Now you have to write, we have only two variables, I and I1. So you need two equations. So you can take one loop here and another loop for this battery, either this loop or full loop. Any loop you can take, any two loops, you'll get the answer correctly. So if I write for this loop, so I'll start from here. I'll again come back to the same point. What is the Kirchhoff voltage law for this loop? So my first loop is A, B, C, D and back to A. So A to B, no resistor. From B to C, along the direction of current, potential will decrease. So minus 5 into I. Remember the convention. Along the current direction of current, if you are going, potential will decrease, negative sign. If you are chosen a direction opposite to current, it will increase, so positive. That's all. So along the direction of current, potential will increase, decrease. So minus 5I. And then you are going again along the direction of current, minus resistance 10 into current, which is I minus I1. Again, still you are from D to A also, you are coming along the direction of current through a resistor. So minus 2I minus resistance into current. And then you are crossing a battery, negative terminal to positive terminal. So potential is increasing by plus 20 equal to 0. So simplify this equation. Minus 5I minus 10I, 15, 17. So minus 17I minus 10 I1 plus 20 equal to 0. So this is the first equation. 17I plus 10I1 is equal to 20. So take another equation for this loop. C. In fact, if you want, you can also go like this. Any direction is fine. C to D D to F, E, again back to C. So in that case, when you go C to D, you are going along the direction of current, potential decrease. So minus, same thing, C to D already we went here also, same result only will come, minus resistance into current. So 10 into I minus I1. And then you are, now if you see, from D to F, when you are going in this direction, you are going opposite to the assumed current value. So you have to do plus I1, 4I1, current into resistance. And then you are going from F to E, from negative to positive terminal. So potential will increase by 10 volt. E to C, there is no resistor. So this is the third equation. This will give you minus 10I plus 10I1 plus 4I1. So plus 14I1 plus 10 equal to 0. Or you get, take it to the other side. 10I plus 14I1 or 5I plus 7I1 is equal to 10. So solve these two equations, find the value of I1. I1 is the current through the value. If you get the I1 as negative, it means we have assumed this direction, but I1 is coming minus 2 ampere, suppose. Then current will be in the opposite direction. This is how you can get the answer. So answer is given as 0.21 ampere from positive to negative terminal. In fact, only one answer is having the value of 0.21. So if I get the answer, that is fine. But they're saying direction is positive to negative. So you can solve this two equation and check the result. Positive to negative means this. So already that is the direction we have assumed. It means value will come as positive. Okay, so note this down. Okay. Right. So there was also another question where you had to use Kirchhoff's law last year, but it did not involve a lot of solving, just writing the value correctly. So let's discuss that also before you go to the next concept. There the current values were given already. So they are not given what is this resistor, what is this resistor, what is this resistor. This current is given as 1 ampere. This current is given as 2 ampere. These two batteries are given. And they ask you to find potential of B with respect to A. So find the potential of point B with respect to A. First, what is the meaning of this statement? So potential of this point with respect to A means if it's at a higher potential or lower potential. They're asking you to find VB minus VA. That is the meaning of potential of B with respect to A. And options are +1, -1, +2, -2, something like that. So how do you approach this? So in questions like this, you can just write the start from one point and go to the other point. So which path you have to go? This voltage, here I don't know the resistance, but only this resistance is given, which means definitely we have to go through this path from A to B to find potential difference. Now, how to find the current in this? It is given this is 1 ampere. So immediately you can write, if there is 1 ampere here, same 1 ampere is coming from here. Same thing will be over here. Same thing will be over here. This is 2 ampere is going here. 1 ampere is only coming from here, which means another 1 ampere would have come in this direction. So for battery anyway, it's the same thing. 2 ampere is coming from here. 1 goes here, remaining 1 goes here. So this is by current law, junction law, we got the value of current in the resistor. So they are asking VB minus VA is equal to what? So you can start from one point. Potential of point A. Suppose you start from here. This point is potential A. When you go through the battery, negative to positive terminal, potential is increasing by 1 volt. So VA plus 1. What is VA plus 1? Potential of this point. Again, go from here to here. You are going opposite to the current direction. Right, we know that current is flowing from higher potential to lower potential. So I told you already, if you're going opposite to the current direction, potential is increasing. So plus I into resistance. So from here to here, you have to write plus, what is that? 1 into 2. So VA plus 1 is potential of this point, plus I into R. 1 into 2 is potential of this point. And then go here, you are going from positive terminal to negative terminal. So potential will decrease by 2 volts. So minus 2 volts. You have reached this point. So this is nothing but equal to potential of B. So this is how you write potential of B with respect to A. After that, VB minus VA means you can solve and find the answer. Take this to other side. So you will get VB minus VA is equal to minus 2 plus 2 will get cancelled. 1 volt. So plus 1 volt is the answer. So the simple application of Kirchhoff's law, current law and voltage law to find potential difference between any 2 points in the circuit. Okay. So you can again go through this video later to understand how to write the plus minus sign. So be thorough with this writing Kirchhoff's law. So you'll have to use that whenever there is more than one batteries. So the next is heating effect of current. So in heating effect of current, we know that, generally you have two formula for power. What is the thermal power generated through a resistor if current I is flowing through this? So power dissipated through a resistor means rate of heat released divided by time taken. So what is the amount of heat that is produced here by time taken is power dissipated. So power dissipated in the resistor is equal to I square into R. Right. So there is also another formula, potential drop across the resistor, V square by R. So which formula to use is a common thing. My suggestion is always go with I square into R, because when you use I square into R, you will not make any mistakes. Because sometimes when you write V square by R, you should not write V as voltage of the battery. You will commonly make the mistake. You have to find voltage drop across each resistor separately. So instead, this current through the resistor is simple. You will not confuse with the battery. So directly you can write I square R as power always. Only one scenario where you can use V square by R is when you have multiple, multiple resistors in parallel combination. R1, R2, R3. everything is connected. So direct parallel combination circuit. Then alone you can go with this, because everywhere V is the voltage drop. So V square by R1 is power dissipated here. V square by R2 is power dissipated here. V square by R3 is power dissipated. So total power dissipated means V square by R1 plus V square by R2 plus V square by R3. Only for parallel combination use this. Everywhere else, any circuit series or some series parallel and both combinations are there, always go with this formula. Okay. So, and also we'll see some question. Before that, you should also know, for ideal cell, internal resistance is 0. But in other case, the cell will have some internal resistance. So every cell will have some EMF as well as internal resistance R. So together, E is called as the EMF of the cell, R is the internal resistance of the cell. So potential drop across the two terminals. This entire device is cell. So VA minus VB, potential drop across the two terminals. We call it as terminal voltage of the cell. What is the terminal voltage of the cell? Terminal voltage of the cell is depending on the current through the cell. So if some current I is flowing, then you can say terminal voltage. Already I told you how to find this. So VB minus I into R plus E is equal to VA. So VA minus VB means this is equal to E minus IR if current is coming out of the positive terminal. So this is your terminal voltage. If current is entering the terminal of the cell, positive terminal of the cell, like this. Why it's entering like this? Maybe some other battery with bigger EMF is connected to this. That battery is creating current through this cell. In that case, if you want to find VA minus VB, the terminal voltage will be equal to E plus I into R. E is the EMF of the cell. R is the internal resistance of the cell. So EMF and terminal voltage are not same. When it will be same? Terminal voltage and EMF will be same if there is no current through the cell. So you don't connect it anywhere. Just simply measure the voltage drop across the 2 points. It will be E only because no current is there. But if you connect it in a circuit, some current is flowing through the cell, then terminal voltage is given by these two formulas. So let's see some question based on this. So its question is given, a battery of 3 volt of EMF 3 volt. In fact, the question is only given battery of 3 volt is connected to a resistor dissipating some power. .5 watts. So SI unit of power is watt, joule per second. So terminal voltage of the battery is given as 2.5 volt. So terminal voltage of battery is .5 volt. So you have to find power dissipated in internal resistance. So first, what is the circuit diagram for this question? So whenever you get internal resistance concept, try to draw a cell with EMF and internal resistance separately, and together you call that as one single device cell, so that you can find terminal voltage across the two ends. In this case, it's a battery. So you have a battery. The EMF is of 3 volt means they are talking about the EMF of the battery. So EMF of the battery is equal to 3 volts. It is connected to some external resistor, capital R. This is your battery. Right. So they are saying battery is having an EMF of 3 volts. It is connected to resistor. 0.5 watt is the power dissipated. That is the first information. Which means if some current I is coming from the battery, so I square R is equal to 0.5 SI units. 0.5 watts. Right. Another term that is given is terminal voltage of the battery is 2.5 volt. Now what is terminal voltage of the battery? I told you it is E minus IR, that is fine. So that value is given as 2.5 volts. But in that I also I don't know, small r also I don't know. But already regarding R something is given. So you should know what is the general definition of terminal voltage. Potential drop between the positive terminal, two ends of the battery, that is terminal voltage. I just gave that equation, VA minus VB. That value is equal to E minus IR, okay. But VA minus VB is equal to 2.5 volts. So VA minus VB is 2.5 volt. So instead of writing it as E plus IR, already I have one term with I and capital R. What I can do is A and B are two endpoints of the external resistor also, because from A you can go through the resistor and reach point B. It means whatever is the potential drop between these 2 points, same is across the resistor, that is equal to I into capital R. So even though it was terminal voltage, that is also the potential drop across the resistor connected above, that is equal to 2.5 volt. So this way you can simply find the value of current easily, because I square is into R is 0.5, I into R is 2.5. So divide both, I square R divided by IR, you will get R, sorry I. Is equal to 0.5 by 2.5, 5 by 25, 1 by 5 or 0.2. So here IR will get cancelled. So I is equal to 0.2 ampere, immediately you will get. So if I is equal to 0.2, you can also find what is the internal resistance, because VA minus VB is also, in any way you can do this, because now you know E is equal to I into total resistance, R plus R, or E minus I into small r is this. Any of the equation can be used, because now anyway we got the value of I, you can find the value of R. I into R is 2.5. So R will be equal to what? R will be equal to 2.5 by current is 0.2 or 25 by 2, 12.5. So EMF is equal to total EMF is current into total resistance, because only one battery, right? So this capital R and small r are in series, because whatever current is going here, same current is going here also. So total resistance is R plus R. So this equation is also valid. Okay, but if you say you don't want this, I just want to directly get the internal resistance from here, that can also be done. Terminal voltage is nothing but E minus I into small r, that is only terminal voltage, which is 2.5. So EMF is 3 volts, current we got 0.2. So 0.2 R is equal to 0.5, right? Which means R will be equal to 5 by 2 or 2.5 ohms. 2.5 ohms will be the internal resistance of the cell. Yeah. So they are asking what is the power dissipated in the internal resistance. Power dissipated in the internal resistance will be equal to I square into internal resistance. What is current? 0.2 whole square. What is internal resistance? 2.5. So 2.5 into 0.04, which means 25 into 4 is 100, and then 1, 2, 3 decimal point. 0.1 watts. So I hope this is clear. Right. So these are the topics like conception, mainly regarding terminal voltage and heating effect. So next you have also some experiments, basically verification of Ohm's law, meter, bridge, potentiometer. So even these devices are important. Questions can be based on those, and more importantly, this voltmeter, ammeter, conversion of voltmeter into ammeter, or conversion of a galvanometer into voltmeter and ammeter. So these kind of questions also will be asked. So let's just see the theory behind that, and then some previous year questions in that topic. So all these comes under electrical instruments. So in case of electrical instruments. So first let's focus on a galvanometer is any device that is used to detect the presence of current. So galvanometer generally you cannot use to measure the current because the range will be very small. You can measure only a small deflection. So if there is no current, it will be pointing in the center. So if current is passing in one direction, it will deflect in rightwards. If current is passing in opposite direction, it deflects leftwards. So it's just used to find out whether current is flowing or not. That is what this is commonly used. Only to detect whether current is there or not. So every galvanometer has some maximum resistance that it can pass through the galvanometer. So IG is the maximum current. IG is the maximum current which can pass through the galvanometer. This IG is generally the value will be very small. So you cannot simply use this as ammeter to measure any value of current, large currents and all. So for measuring current, you just devise an ammeter using the galvanometer. So how to convert this galvanometer into a ammeter with some range? Instead of here you can measure only up to IG. I want to measure up to the IG will be in milliampere or microampere also. Only 0.5 microampere. But you want to measure 2 ampere, 100 amperes. So if you want to measure large currents, how to convert this galvanometer into something which can measure larger current? So what you do is, so converting this to conversion of galvanometer to ammeter. I'll just give the equation and the circuit diagram and how to remember that. Let's not focus on how exactly the deflection, converting the angle turn, all those things. So what you do is you connect a shunt resistance in parallel. So if you connect a shunt resistance in parallel to a galvanometer, shunt resistance means any resistance which is connected in parallel whose value is very small. A small resistance is connected to the galvanometer. Right. Another term also is that what is the resistance of the galvanometer? So that is G. G represents resistance of, or any symbol you can use, RG. That is also fine. So this represents the resistance of galvanometer. So into an ammeter, but what is the requirement? Ammeter with some range. So ammeter of range from 0 to I max. Up to I max you want to measure. So if you want to measure up to I max, what is the maximum current that can pass through this? So how to write the equation is, when that maximum range is 0 to 2 ampere means when 2 ampere is passing here, most of them will go through the shunt, smaller resistance. Only the IG will be going through this. That is the condition. So when outside current is maximum, galvanometer current should also reach maximum. So you want to measure up to 2 ampere means when 2 ampere is flowing, this current through the galvanometer should be the value of Ig. That is a property of a galvanometer. How much maximum current can flow through this? If we pass more current means it will get destroyed. So only Ig is the maximum current that can pass through the galvanometer. So when current, this device together is called as, this box, we will call that as ammeter. Okay. So when Im is passing here, Ig will pass here, which means large current is coming, only small is going here, remaining should go here, which means remaining Im minus Ig will flow here. So how to find Ig and Im relation? Already I told you, parallel branch. You can take it like two resistors. Here resistor is G, here resistor is S. This current is Im, this current is Ig. So can you say current through the galvanometer is equal to total current entering the junction into other resistance divided by sum of two resistance. I gave this in the starting of the class. So this way, if they give you what is the maximum current that can flow through the galvanometer, what is the requirement of maximum current or maximum range of the ammeter that you want, and galvanometer resistance is also given, you can find the value of S. Solving this equation, everything else is known. You can find the value of S. That is the shunt resistance. You have to connect parallel to the galvanometer so that the galvanometer can be converted to a ammeter. So is this formula clear? Right. Converting to voltmeter is even easy because it's a series combination. Series, it is easy to write the equation. So if you want to convert this into voltmeter, voltmeter of some range 0 to V max, up to this much voltage the voltmeter should measure. Right. Yeah. So up to 0 to V max it should measure. So in this case, what you can do is you can connect this galvanometer, and series with that you can connect another large resistance, high resistance. Together this box is voltmeter. What is the equation? Now what is the maximum current that can flow through the galvanometer? Ig. So when Ig is flowing through this, Ig is coming here also. In that case, this potential drop should be equal to maximum value it can measure. So V max will be equal to Ig into resistance of this voltage plus G. Current into total resistance is total potential drop. So total potential drop that can be measured by this voltmeter will be equal to this value. So this, if you want to convert it into voltmeter, which can measure 5 volts. So 5 volt is equal to Ig into Rv plus G, which is resistance of the galvanometer. So this is the equation for converting galvanometer to voltmeter. Okay. Right. So there's a question based on just this equation in last year JEE means also. So it was given galvanometer of resistance G is converted into voltmeter of range 1 volt, 0 to 1 volt. So in the question it was given, we are converting into voltmeter of range 0 to 1 volt by connecting R1, another resistor R1 in series with the galvanometer. So by connecting R1 in series with galvanometer. Right, this information is given. And then they gave how much extra additional resistance that you have to connect. So additional resistance R2 should be connected in series so that range of the voltmeter becomes 2 volts. Up to 2 volts it can measure. This information is also given. The additional resistance that should be connected in series with R1 to increase the range of the voltmeter to 0 to 2 volts. And then they ask you what is the value of R2. Find R2 in terms of G and R1. The options were G, R1, R1 plus G, or R1 minus G. So how to approach this? So just write the general equation for converting this. So 0 to 1 volt means maximum voltage. 1 volt is equal to current through the galvanometer into G plus R1. This is the first equation. Second equation is range is 2 volt means maximum voltage. Maximum voltage is equal to current through galvanometer into, apart from R1, we are connecting one more resistance in series R2. So how to find R2? Compare these two equations. So you can write, in fact, if you want, you can divide these two equations. Ig will get cancelled. So 1 by 2 is equal to G by R1 divided by G plus R1 plus R2. So take this over here. G plus R1 plus R2 is equal to 2 into G plus R1. So we want to find R2. So R2 is equal to 2G minus G, 2R1 minus R1. So solving this, you get the answer directly. So this direct application of formulas, if you are clear with the concept of how to convert this galvanometer to voltmeter or ammeter. So small topics will be there. Focus on everything because you do not know which question you will get in your shift. So every single concept in the chapter, make sure that you are thorough with the formulas regarding them. Then most of them will be direct application of formulas. Then next is meter bridge and potentiometer. Meter bridge is nothing new. It is directly Wheatstone bridge only. So in case of meter bridge, you will have a resistance, some unknown resistance R and known resistance, right? And then it will be connected to some long wire, and then there will be a battery, maybe some rheostat as well. So the galvanometer, jockey. This is the experiment I hope that you will be doing in lab with the meter bridge. So meter bridge works on the principle of Wheatstone bridge. You have a 1 meter long wire. So if this length is x centimeter, remaining length will be 100 minus x centimeter. The aim is to find the where should we keep the jockey so that no current is flowing through this galvanometer. If no current is flowing through the galvanometer, you will get no deflection. So in that null point will happen when it is a balanced Wheatstone bridge. So R1 by this resistance is equal to S by this resistance. And then we'll use the property resistance of a wire is directly proportional to the length of the wire. So you can say this resistance R1, this resistance R2. So R1 by R2 if you want, this resistance by this resistance. Resistance is rho L by area, right? So resistance is directly proportional to length. Here because resistivity is same, area is same for both the resistors. So R1 by R2 is ratio of length x by 100 minus x. So and then Wheatstone bridge is R by S is equal to R1 by R2, or R by R1 is equal to S by R2. That is the condition. R by R1 is equal to S by R2. So R by S will be equal to R1 by R2, which is X by 100 minus L. So you should be clear with the terms. That question directly based on this experiment can be answered. Okay. And let's go to potentiometer, which is where you might face more difficulty because circuit looks slightly complicated than this meter which. So when you talk about potentiometer, what is the principle behind working of potentiometer? It is not Wheatstone bridge. Only meter bridge works on the principle of Wheatstone bridge. Principle behind working of potentiometer is resistance of a wire is directly proportional to its length. That is the principle that you will be using here. So here you have two things. You have one primary circuit, E1, maybe some rheostat is there, and that is connected to a very long wire. You might have seen in lab, the same, it will be very long that it will be bent into multiple parts, but concept remains same. So this primary circuit, some known battery resistance is there. You won't disturb this. So that current, there is a constant current flowing through the wire. This potentiometer can be used to find some EMF of an unknown cell and known cells comparing two EMF, or also to find internal resistance of a cell. So first, if you connect this with the one cell E1, right here some key will be there, and then another cell E2, another key will be there, and then you will connect to a galvanometer, and then you will try to fix any one key. If key 1 is fixed, then this cell is only connected. This is not part of the circuit. So when you are connecting E1, positive terminal is connected here, negative terminal is passing through the galvanometer. Check where you keep the volt, like this jockey. At one point, no current will be flowing through this. Current through the galvanometer is 0 at one point. Check that length. So if current through the galvanometer is 0, when key 1 is connected, you will get one length L1. So this EMF is equal to this EMF. So E1 is equal to potential drop from across length L1. So potential drop across the length of L1. How to find potential drop across the length of L1? That is simply what? Current through this into resistance of length L1. Current through the wire into resistance of this length. That is the potential drop here. This potential drop is equal to E1. Then only no current is flowing through the galvanometer. So resistance of E1 means resistivity of the wire, length L1 divided by area. So all these terms are constant. So we call it as phi into L1. So this voltage across length L is equal to some constant times length L. This constant phi is called as potential gradient. Potential gradient because what does that constant represents? V by L. Potential drop across length L1 is some constant phi into L1. That constant is potential gradient of the wire. Because across the full thing, maybe some 10 volt is dropping. So half the wire, 5 volts will be dropped. Quarter of the wire, 2.5 volt will be dropped. So 10 volt divided by 1 meter, if it's 1 meter. That is potential drop across the wire. So potential drop across the wire is constant. That constant is phi. So that we can write potential for length L1 means phi into L1. Similarly, if you put T2 is connected and then some other length you will get for second battery. So E2 is equal to phi into L2. If you divide both, phi will get cancelled. E1 by E2 is equal to L1 by L2. L1 is the length you get when this key is closed. L2 is length you get when the second key is closed. This battery is connected. This is removed. Some other length you will get. So like this, you can compare EMF of two cells using potentiometer. Okay. The other experiment from this device is to find internal resistance. How to find internal resistance? Of a cell. So what you do is, cell means immediately you write E and R together is your cell, and then some external resistance you connect. This value is known, and then you put a key here. So when key is open, if key is open, this R is not connected, not part of the circuit. So only one battery, we are finding null point. Since no current is flowing, no current is flowing through the resistor. If no current is flowing through the internal resistor, terminal voltage will be equal to EMF. I told you in the beginning, right? E minus IR is terminal voltage, but no current is flowing here. IG is 0. So at null point, no current is flowing. So even if internal resistance is there, it will not affect the answer. So E is equal to voltage drop across length 1. So if key is open, the equation is E is equal to phi into length L1. You are getting length L1 for no current through galvanometer. Similarly, if key is closed, you will get some other length for no current. If key is closed, then what will happen? I will redraw this. So if this key is closed means it is like you are connecting this. Now also no current is flowing. What is the meaning of this? Definitely if key is closed, this loop is complete, circuit is closed. So some current I0 will come from here. I0 will go here. It will go here. It will again come back to the cell. Because nothing is going through the galvanometer. So whatever is going from the battery should come back here. Nothing will enter this also. So just because this circuit is closed, this current will not be disturbed. So this potential difference, that gradient, everything will still be same. So now what we can say is this potential drop is equal to this potential drop. That's why no current is flowing. So now you are getting some length L2 because key is closed. This resistor is part of the circuit. You are getting some length L2. So which means this potential drop is equal to this potential drop. This you know, phi into L2. So phi into L2 is equal to potential drop across A and B. So potential drop across A and B. Either you can write E minus I0 into R, or you can also write I0 into capital R. Both are correct. So I0 into capital R. What is I0? Current in this branch is EMF divided by total resistance. Just now we saw some time back one question based on this. So E divided by capital R plus small r is I0. E divided by capital R plus small r is I0 into R is equal to phi L2. So from these two equations, if you divide second equation by first equation, you can get the value of internal resistance. That formula also you have to remember. So our equation 1 divided by equation 2, E divided by E into R divided by R plus R is equal to L1 by L2. So final result will be, I'll write that here. R plus R divided by capital R is equal to L1 by L2, or 1 plus R by R is L1 by L2. So R if you want, L1 by L2 minus 1, that is R by capital R. So into capital R will give you internal resistance. I know what is the known resistance. I know what is L1, length when key is open, when the external R is not connected. L2 is balancing length, so that no current is flowing through the galvanometer. So length L2 when key is closed, when that R is part of the circuit, you are getting L2. This is L1. Definitely L1 will be more than L2 always. This you should know. In the circuit always L1 will be greater than L2 because initially potential is E. Now this potential is E minus IR. So it is decreasing. So this is your, this formulas also you have to remember. There will be direct questions and the concept behind this and what is potential gradient. That will also be useful in solving the question. So we can maybe discuss a quick question based on this. So we'll discuss the question which was not directly based on formula. Right. So there's a question. Length of a potentiometer wire is potentiometer wire is 120 centimeters. That is given. And this is also last year JEE main question. It is carrying a current I is equal to 60 milliamperes. So if you want for a cell of EMF 5 volt, so for a cell of EMF 5 volt and internal resistance equal to 20 ohms, null point is found at 100 centimeter. So null point means point where no current is flowing through the galvanometer. Null point is equal to 100 centimeter. So from this information, you have to find the resistance of the full wire. Whole potentiometer wire. So how to find resistance of whole potentiometer wire? So if they ask resistance of a wire, immediately you should know they are talking about voltage across the wire by current through the wire. So potentiometer wire is present here across A and B. So this resistance for the whole wire means potential drop from A to B divided by current through the wire. So it is given 5 volt is 5 volt battery is there. This potential, it is connected to some external circuit. Leave that. Current is 60 milliampere is flowing through the wire continuously. But for a cell is 5 volt and internal resistance 20 ohms. We are getting a balancing length of, what is the balancing length? 100 centimeters. We are getting a balancing length of 100 centimeters. Which means potential drop for 100 centimeters is equal to 5 volt. Because anyway we are getting null point. So no current through the galvanometer. Internal resistance doesn't matter for finding EMF of a cell and balancing with the length. So we can say that 5 volt is equal to potential drop for 100 centimeters. So from here you can find the value of, you want what is the potential drop for full wire, right? In fact, the resistance of the full wire is asked, right? So you want potential drop of the entire wire. So best way is you can find potential gradient. What is potential gradient? Voltage drop of 100 centimeters, potential drop per unit length, right? So potential drop per unit length is total 5 volt is dropping across 100 centimeter. So if you want potential drop for wire AB, can I write that as potential gradient into length AB? What is potential gradient? 5 volt by 100 centimeter. So 5 volt is dropping for 100 centimeters. Total wire length is 120 centimeter. How much voltage will drop? 5 by 100 into 120. So that is the total potential drop across the full wire divided by the current. Current is given as 60 milliampere. So divided by 60 into 10 power minus 3. So centimeter will get cancelled. So this will be equal to 5 into 120 by 100, which is 6 by 5. divided by 60 into 10 power minus 3. So all this, that will be the resistance of the whole wire. So I hope this is clear. So the balancing length 5 volt is for 100 centimeter. So for 120 centimeters, what is the total voltage drop? We know that voltage drop is proportional to length. That is potential gradient. Total voltage by length is constant for the entire wire. So this is the potential gradient, voltage drop per unit length, into length AB, which is 120 centimeters. They will give you voltage drop across AB, divided by current through the wire will give you resistance of the full wire. So we have covered almost all the topics in current electricity and last year JEE main questions based on the same concepts. So that's all in today's class. So we'll end this meeting now.